I guess we will start. Is here anybody who doesn't speak Czech, Slovak? Okay, then we will do it in English. That's totally fine.
Nice.
I'm just asking. Okay, so welcome on another BrnoJUG talk. Today we have Matěj Novotný talking about CDI. As usual, after the talk in room 83321, there is some after party, some food and drinks. So after we finish here, just go to the end of the hall to the left. Toilets, which I always forgot to mention, are after the glass door to the left, opposite to the elevators. And with that, I will give word to Matěj and we can start. So I will
Thank you.
And now you can start.
Okay. Thank you. So thanks for the short introduction. You spared me some work there. I'll just mention that I'm also a commenter on the CDI specification and I work on some of the implementations, 2 of them. So just that you know, I might know a thing or 2 about these things. During the presentation, please, if you have any question about regarding what I'm talking about, just raise your hand and I'll try to answer it. If it takes too much time, we can discuss afterwards during the after party. So what I'd like to cover is first a brief history and usage so that we have the common picture, and then mention the current specification structure. You might have heard something about CDI Lite and full going on lately, and then we'll dive into the capabilities. There I'll ask you the question whether you know or don't know some of the capabilities. We can speed up or slow down. I have some examples in the code. We probably won't be able to cover all of them, so I'll try to adjust based on what you know and you don't know. Because obviously the dependency injection is something I assume you're familiar with from one framework or another, but I would like to also showcase some other capabilities like the events, interceptors, or extensions. So a brief glimpse of the history and usage. First CDI 1.0, that was part of the Java EE 6, not developed by Oracle though, it was developed by Red Hat, and thanks to that, it had back then, and it still has a nice community and is being developed and changed. Another notable milestone will be the 2.0, where we pushed forward some of the CDI SE API, and since then you could use it in literally any SE application and bootstrap your container and your injection and stuff. And yeah, 3.0, that's the infamous Java extra card change if you came across that. And we'll be mostly talking about 4.0. That's the latest. That's the latest final release that you'll be working with if you run on something like Quarkus, Wildfly, and the latest versions of those. That's 4.0. 4.1 is currently being brewed. It's scheduled for late February, if I'm right. All right. All the usages, like I said, it was originally created as part of the Jakarta EE and still has a core dependency. It's also used by microprofile. It's usable standalone in SE, like I said. It's at the core of Quarkus. That's a CDI Lite implementation. Helidon used it. That was Weld SE implementation last time I checked. And BrnoJUG was cooperating with us for their annotation processor approach for the 4.0 version. I'm not sure if they're passing the TCKs by now. We haven't heard of them for a while. Okay, if you ever happen to, by accident, open the long specification, you might see the 3 big bullet points there, which is core CDI, CDI SE, and CDI EE. We'll mostly be talking about things from core CDI. That's the base set of features that CDI has. And those have been split, starting with CDI 4.0, into what's called CDI Lite and CDI Full. So if you have had any experience with CDI before, you basically know what is now called a CDI Full. That contains the full set of CDI features, be it interceptors, decorators, portable extensions, whatever. CDI Lite was created as a subset of those features, and that's important because whatever you use in CDI Lite, you can use in CDI Full. And those features are designed for more like smaller applications, microprofile applications, let's say, microservices, I mean, and also to work in like restricted environments, such as the build-time environment of Quarkus, for instance, or in the annotation processor approach of BrnoJUG. To mention some of the things that are excerpt from CDI Lite that are only in CDI Full, those are, for instance, the portable extension, some of the scopes like session or conversation, and decorators, specialization, but the core features basically remain. Also, I should note that the API for CDI stays the same. You're still going to use the same jar, which basically has all the access to all of it. It's just that CDI Lite implementations are just bound to implement a certain subset of them, but at the same time not restricted to implement others if they want to or can. Okay, CDI SE, we'll see just a bit of it because that's what I'm going to use in my examples and in my tests. That's just a very simple API built on top of CDI full, so giving you access to every feature CDI has. And you can bootstrap it basically whatever you want and configure the container to your liking, like enable, disable discovery, add some synthetic beans and so on. And last part is CDI EE. We'll not touch upon that really. It's just a base of additional rules for Jakarta environment regarding, AGB integration, name resolution, and other stuff. All right. As for the CDI capabilities, I'll be using a very simple GitHub project with a link here that you can run and check out yourself if you want to later. It's not anything special, just all the sources I basically separate into packages showing various capabilities that I'll be talking about. And then there are JUnit tests asserting on those things so that you can verify it. As an implementation, I'll be using Weld SE. And just for the sake of clarity, the JUnit also uses Weld JUnit 5 extension, which helps me bootstrap the CDI container in every JUnit test for me. Okay. I actually can show you a bit of the app. There's nothing special there. Just like I said, in the main you have some bean definitions that I'll be describing to you. There is a main class in which I can actually show you the bootstrapping of the SE container. This is basically all the code you would need to start a container, like the CDI container in any SE application. It is a very simple API, just an initializer with a static method, and these are already my own configuration where I'm saying disable discovery, which is basically saying CDI like, hey, don't look at the whole class file, don't scan everything. And here I'm telling him just manually add some of the classes that you should consider beans. And then you do the try with resources block, and everything that's happening inside is already in the container. So your injections, your interceptions, all of that work there. And the same approach is then used in the tests. But like I said, I'm using, show you some of that. I'm using a JUnit 5 extension, which is demarked by this annotation. It's just, you take a look at here, it's just the JUnit extend with. So what does this for me is annotation-based approach where I can just use a bunch of annotations to do the same that you saw in the test, pretty much the exact same thing. I'm adding some of the beans manually, otherwise it automatically disables the discovery so that the deployment is minimal, and it automatically starts the container for every single test method that I'll be running. Just that we're clear on how that works. All right, so how many of you are familiar with CDI with regards to injection? How many of you have come across it? Right, that's, I don't know, 1/3 maybe, that's nice. So some of this is probably going to be a bit boring, but I need to get us on the common ground, so please bear with me. So when we talk about CDI, we need to talk about what a managed bean is. That's standing at the core of it. Managed bean is your Java class, which has some restrictions on it, on becoming a managed bean. A managed bean means that the whole lifecycle of the bean is going to be managed by the CDI container. That includes initialization, injection into your bean, and finally, when the context ends, destroying that bean for you and calling like anything like pre-destroy callbacks that you might have on it. Right. Then there are some additional possible restrictions if you want to have your bean proxyable. That happens if you need an interceptor decorator or a so-called client proxy. That concerns quite a lot of bean. You might have seen the annotations like add application scope, add request scope, and those are all so-called normal scopes and require a client proxy. What that basically is you're going to get, when you inject your bean, you're going to get just a stateless proxy that somehow knows how to resolve the bean once you first try to reach it. For that reason, it needs to have non-final class, non-final methods, and no arg constructor. So those are just like some technical limitations. And this can be a bit limiting for your application, and sometimes you, for instance, cannot meet some of the requirements. Like, for instance, that the inner classes cannot become a bean. So you can work around that by using something called producer methods or fields. So those are two different ways that you'll be defining your beans. Either it's a class that needs to have some, I forgot to say that, sorry. The class needs to have something called a bean defining annotation to be discovered by CDI for you automatically. You'll see those in a bit in the code. The producer method or a field is a method or field placed on the managed bean itself that works as a bean definition. Let me show you a bit of that. Where was I? Right. So if you want to write your own managed bean, it's going to be some simple Java class. Here I have the add application scope. This is what's called the bean defining scope. It's one of many that you can use here. I'm going to talk about what contexts and scopes are in just a minute. And then it uses can use but doesn't need to sort of qualifiers. Otherwise, it needs to have a certain constructor, which you can see that I have here. I annotated my constructor with add inject, showing CDI. Basically, if you want to instantiate this bean for me, you're always going to use this. And that also means that whatever parameter I'm specifying here is going to be an injection point, and CDI will try to automatically resolve it for me as well. Right. Now 2 more classes here, just to show you what some of the cases where it won't work. First, this one. Technically, it's a valid class. It's not an inner class. It's a static class, but it doesn't meet the proxyability requirement that I mentioned earlier, because it requires a client proxy due to the scope annotation, but it doesn't have an OR constructor. So if you try to do something like this, you would see Weld log a warning for you saying, hey, this is not valid. It's not a hard error, it's just a warning. The reason being, you can basically write a producer for this bean, which is exactly what I did here in the other class. Take a look at that. This is my producer class. Again, it has to be a managed bean, so I just chose application scope for the purpose of this. It doesn't really matter what the scope is. And I'm showing 2 various producers. This one is for the bean that I just showed that cannot be discovered by default by CDI, so I can work around that by writing a producer method. The key point that you need here is the add produces annotation on your class. That's what CDI scans and uses to discover, hey, this is effectively a bean definition for him. And then you can define what scope the bean can have. This is the dependent. I could have the application scope there instead, for instance. If I don't define it here, there is a default. That's the dependent one. And again, there can be some qualifiers. Now, when I talk about CDI qualifiers, they look something like this. It's a plain Java annotation, which needs to have a retention policy runtime and needs to have the CDI add qualifier annotation on it. The literal is not needed, just for me to be able to refer to an instance of this annotation from the code. Let's take a look at what CDI contexts are. So you might know dependency injection from, I don't know, Decorators or maybe Spring. But not all of them, if any of them, actually, I'm not sure, use contexts. In CDI, every bean lives within exactly one context. So the context has associated scope. For instance, application context and application scope, that's activated for you when the application starts and lives on until the end of the application. So if you have a bean there, this is an ideal scope to share the one instance of bean throughout your application in all of the injection points that you're going to use. There are some shorter lived scopes like request scope, typically HTTP request, right, but not limited to that. What's interesting is the dependent scope. The dependent scope is special in that every injection point leads to a creation of a new instance of a dependent bean. So dependent beans are basically, their life cycle is bound not to the not within their own context, but within the context of the bean they have been injected into. As an example, if your application scope bean declares a dependent bean injection point, that dependent bean is going to live within the application scope bean for as long as the application lives, because that's how application scope works. But if you do that within your request scope bean, that bean lives as long as the HTTP request is running. When it ends, it's killed. And if you have the dependent bean in it, that one is killed along with it. By killed, I mean basically cleared out, calling any pre-destroy callbacks and anything you might have written for it. Right, one notable thing is the context that you're trying to resolve might not have been active. If you did something with CDI, you might have seen this very popular exception. That can happen when you're trying to reach, for instance, a request scope bean, but there is no HTTP request running, so the context hasn't been activated for you. So you have to watch out for that. Right, let me show you a bit of code. Okay, here is a simple example of a request scope bean. Again, it's a managed bean. I have to give it some bean defining annotation to be discovered. That's request scope here. And then I'm injecting a dependent bean, and it has a single method that just delegates to a method on the dependent bean. Then I have the very same bean. It just has a different scope. It has a singleton scope. Just beware if I'm talking about singleton, I'm talking about Jakarta inject singleton, not the AGB singleton. It has nothing to do with that. If you take a look at the dependent bean, this is what it looks like. Like I said, every dependent bean, the instances of dependent bean are created for every injection point. So each of the two beans, the request scope and singleton, will have its own instance. And this is basically to assert exactly that. Here I'm using a constructor annotated with inject, so I'm telling CDI this is how you instantiate it. And when you do, give me an instance of an injection point. This is a very special, like a built-in bean that you don't need to provide in your application. The container will give it to you. And only dependent beans are eligible for this. Everything else would give you an error. This is pretty handy though, because since dependent bean can be injected into various places and you get a new instance every time, you might want to ask the container, where am I being injected? Show me the information about the bean. And that's basically what I'm doing here. I'm checking, like, give me the bean that requested my injection and give me the Java, the for reflection Java class that did that. And I'm storing that as an information inside the bean. Now, if I show you the test real quick. No, this one. Right. So here I have the test. Like I said, it's the Weld JUnit, which also allows me to do all the add inject straight on the test class, which would normally work for you, obviously, because the test is not a CDI bean, so the injection wouldn't work out of the box into any place. Here I'm injecting the beans I told you, the request scope, singleton dependent. And if you try to verify what happens, so first off, if you check the request scope bean and try to call the ping method that we have, it would fail. Because like I mentioned, the request scope bean lives in a context that's not active. There is no HTTP request existing here. So first of all, you'd get context not active exception. However, some context, namely the request context, can be activated. There is a neat trait for it, and that's this one. It's another built-in bean that CDI container provides for you, so you're not defining this yourself. This is given to you if you just ask for it. It's a simple controller which has just two methods, activate and deactivate. Allows you to, at any point, say, hey, from now on, I want the request context to be active. And when you're done doing whatever you consider to be a request, then you just deactivate it, which is exactly what I'm doing here. Oh, looks like I'm not anymore. Good. I swear I didn't touch it, I think. Okay, yeah, and once you activate it, you can just do the assertions which I told you, which verify that the instance of dependent bean is actually different in every of those beans. Okay.
Question?
Yes?
Can you, I have a framework that will activate the request scope for me. Can I activate, like, or deactivate it myself from my code?
Yes. Okay. To be precise, there is the activate method returns a boolean which tells you if you activated it, because it may be that in the moment when you're trying to do that, it's already active. So in that case, you get a false, and then if you try to deactivate a context you didn't activate yourself, that would be an error. I will throw for you. Yes?
Well, in Spring, it's thread bound. Do you have similar mechanism?
Thread bound, what do you mean? Like the request scope?
Yeah, like you have like beans that are request scope. They are bound to the thread of the request. So
yes,
like it's thread local. So we have similar concepts.
Yes, yeah. It works pretty much the same. Like the application scope is across the threads. You can access it anywhere. So you should be aware of that. If you want to do that, they should be thread safe. That's on you, your beans. But the requests contexts are usually thread bound. That's the kind of a default implementation.
And can you define your own scopes?
Yes, I was exactly going to point out that. You can
just before you move on.
Yeah.
Context propagation.
Please no. No, what do you mean? Just kidding.
With context propagation, you can propagate it on request scope, right?
You can, but that's outside of bounds of CDI itself.
Okay.
Right.
But specification can do this.
Okay.
Yeah. You can cross the boundaries. Just it's not very easily done, because if you think about it, that your bean can have something like a pre-destroyed callback defined, and then if you start like sharing the context across many threads, then where is the boundary? Where do you cut off? Where does the HTTP request actually end? And if you do that, and if you call the pre-destroys and other threads are still working on it, is it a valid state? So it's a bit of a problem here.
I would kind of expect to interact with structured concurrency this way, maybe. Do you have some plans for it? Structured concurrency.
Structured concurrency? No, I'm not sure what you mean here.
Well, structured concurrency is a way to define this interaction between threads, like declaratively. So you say, hey, I need to start these 50 threads and do something. And you like inherit it into them, and then when they are all closed, you can close all the scopes.
Could be, but CDI itself is not in control of the threads. You are. So if you do that, it would work.
So I could write a scope that does this.
Yes, or if you just have a thread pool into which you're propagating it and it follows these rules, then it will work for you. But CDI has no idea how many threads you're going to use. It doesn't have its own executor. Right, and you asked about the custom scopes. So you can do your arbitrary scope and context. And I think the application theoretically even allows you to replace the existing context, but I don't think anyone ever tried that. Some of them that you might have heard about is, for instance, if you do know Jakarta transactions, there is the transactional scope. That's basically just an implementation of a custom scope in CDI. Another one that's pretty prehistoric one if we talk about JSF, but they used to have a view scope too, as another example. Obviously, when you have your own scope and context, that requires you to control its boundaries, like when does it activate, when does it deactivate. It's not trivial, but it can be done.
Maybe one more question, because many people are not familiar with it. What is the difference between application scope and singleton?
Good one. So application scope and singleton are both scopes that activate as soon as the container starts and live until its end. The difference there is that application scope is so-called normal scope, so requires a client proxy. Whereas singleton scope is not, and will just, the reference that you'll get if you do, actually, here, imagine you inject your bean just like add inject foo. If this is a singleton scope bean, you're directly looking at the reference of the instance of the bean. Whereas if it's application scope, you're actually getting what's called a client proxy, which is a stateless object for where you, for instance, shouldn't try to access its fields directly. You should use methods, get, setters, and so on. Otherwise, there is no real difference. Both can be, I don't know, intercepted, decorated. It's very similar. Just a singleton bypasses some of the limitations that I mentioned earlier for proxyability, such as having no args constructor. Okay. When you talk about injection, there are two main ways to do it. First is the one that you saw in the test, where I do just add inject and the type of the bean that I want to. Optionally, you can also define the qualifiers as you saw. The qualifiers are typically useless if you have more implementations of the same type and want to differentiate them based on the qualifier or a set of qualifiers. It's not just limited to that, because as you saw in the code, I also mentioned that some of the constructors are automatically getting injected into. So constructors, producers, observer methods, disposers, probably some more. And the other way you can do this is programmatic lookup. There are two ways to do that. First is when you can perform your injection, you can get a handle on this so-called instance, and from there you can dynamically resolve any bean you want, and you can basically say, hey, give me a bean that has this type and these qualifiers, and only at runtime you say .get, and it tries to resolve the bean. This can be handy if you don't know the exact time or the set of qualifiers up until you get to runtime. But some of you may be familiar with this last one, which is a static way to access the CDI container from anywhere in your application. This can be even like non-CDI objects, it's non-beans. And this gets you to the container, and basically from here on it's the same as using the instance. You can say, select the bean of type foo with qualifiers, add fast for me. You just have to be aware that normally CDI does a validation of your whole application once you start the container. So every injection point that looks like this is going to be validated. And while the container bootstraps and you don't have the bean type foo, it's going to tell you and blow up. This is not the case here, obviously, because it doesn't know what you're going to ask for until you do. And there are methods to help you with that. You can query it and ask if the bean is resolvable. Right. How does the injection actually work? There is something called Typesafe resolution. It's a basic mechanism that matches the injection point and the bean itself. When I talk about injection points, it's any of those at inject places or the parameters of the methods that get injected. The important part is they have so-called required type and a required set of qualifiers. And those are matched against a set of beans in the container, which each bean has a set of its types, typically transitive closure of the type of the bean. If it's a producer method, it's a closure of the return type of the method, for instance. This can be modified by extending in some annotations, but let's keep it simple. And each bean also has its own set of qualifiers. And for it to become a match, to say that I have a bean that fits into your injection point, the bean has to have all the required type and all of the required qualifiers. Typically, the bean will have more qualifiers than your injection point requires, and that's perfectly fine. Because CDI does this out of the box for you and doesn't want your input, this means that there has to be exactly one bean matching every injection point you have in your application. If you're not using the dynamic resolution, that is. If you have no beans, you're going to see something called unsatisfied dependency resolution exception. If you have more, it's going to be ambiguous one. Right. Take a look at that. Actually, yes, it's pretty much seen from this, so probably it will be super fast. Let me just mention a few other things, yeah, because I'm halfway through already, I see. Some other notable mentions for injection would be alternatives. CDI allows you to declare a so-called alternative to a bean, which can replace it in any injection point that it fits normally. This can be handy for something like your test environment where you want to replace the production bean that does some logic with your database or something, and you basically want to create a mock. You can do that with so-called alternative. You use the normal way of declaring a bean. You just add the alternative annotation on it, and you need to enable it or select it with something called priority annotation. Notably, this doesn't fully disable the original bean in terms of if they have different types, you could still do some tricks to get your hands on the original bean if you really try hard. And if the original bean has some, for instance, producers or observers defined in it, those will still work. I can show you quickly an example of what an alternative looks like. By the way, for every single one of those things I'm showing, there's tests here, but it's basically just an assertion of what I'm saying, so I think that would be a waste of time. Right, if you take a look, let's just interface. So assuming I have this very simple basic foo bean, application scope manage bean with a single method, and I want to write an alternative for it. So an alternative could look something like this. I give it again a scope annotation to make CDI discover it, and here I intentionally used a different scope from the original bean, so the alternative can change some of the metadata of the bean this way. It can also define qualifiers, obviously, but my original bean had no qualifiers, so I have no qualifiers here. I add the alternative annotation, and I added the priority. What you're seeing here is just a list of some priorities that are predefined for libraries and applications and so on. Just think of it as a predefined number. Yeah, the point is it's using this number and it's using +1, so it has effectively 2001 in the number that I have there. And you can have multiple alternatives implementing the same interface. Here is another one that has exactly the same config, but I used a higher priority. So the thing is, the highest priority will win over and be injected into wherever the original bean would fit. So this can be handy if you know there are already some alternatives in place, but you need yet another behavior maybe. And what is that? Yeah, in this test for the alternatives, we're basically, by the way, using the programmatic lookup approach through the instance that I mentioned, where I dynamically selected. I'm also showcasing that I can actually deliberately select the other alternative that has the lower priority. And the reason why I can do that is because I'm just asking for a bean of type alternative foo, and that's the only bean in the whole application. Because if you take a look, show you, right? So we have the basic bean that's just basic foo, and then the alternative extends the basic bean, and the other alternative extends the basic bean as well. So there is only one bean of the type alternative foo. That's the first one, so I can still get my hands on it if I try. If you want to somehow avoid this happening, there is something called specialization in CDI, and that's CDI full feature only. That works pretty much the same as alternatives. It's bound to give you some headaches because it disables the original bean, so that would prevent me from getting my hands on it, prevent any observers or producers working, and it makes the bootstrap of the CDI container much more complex, but in some cases it can be useful, but most of the time you can just solve your issues with alternatives. Now, the examples I showed you were pretty much simple classes to keep it simple, but you can work with generics, obviously. There are some special rules for that. I'd probably not put for that. There is a whole section in the CDI specification on how assignability works in that case. Just to let you know, this is a possibility. Okay, let me move away from injection and talk about events and observers. That's another programming model that CDI allows you to use. So observers are basically methods on your managed bean, so it has to be the class-based bean. And the method has a parameter annotated addObserves or addObserves async. As you might have guessed, that's either a synchronous or asynchronous observer. And when you want to fire the event, you're going to use some special event interface that I'll show you in the code in a bit, from which you can do either fire or fire async, and respectively fire a synchronous event or asynchronous. Notably, if you fire synchronous, it only notifies synchronous observers, and the other way around. If you want to notify all of your observers, you have to specifically fire both events. This is because they both have a slightly different exception handling. Notably, the async one returns you a completion stage. So you can hook up any calls you would normally to completion stage, like on error or some stuff, or just wait for completion if you want to. Now, how the observers and events are matched is called observer resolution. And this is very similar to the Typesafe resolution I mentioned earlier. Just think of the observer method as the injection point saying, hey, I'm looking for an event of type foo and certain qualifiers, and then the event having certain types based on what payload you fired with and what qualifiers you fired with. Then there is something called conditional observers. Normally, observers are delivered into beans, beans within their respective context, and the bean is created if it's not already existing. Then the event is delivered to it. If you use conditional observers, you can avoid this and say, hey, I only want to deliver the event to my observer if the bean was already existing by the time I invoke this. It's a bit of a niche use case, but a nice one. I'll show you how that looks. Then we have transactional observers. I won't be showing those because I'm running the Weld SE example and there is no integration with JPA. But if you were in something like Jakarta environment, you could use this and fire events related to the transaction in progress, and that observer gets notified when the transaction reaches a certain stage. So let me show you how some observers look like. Like I said, it has to be in a managed bean, so I again have a class that has some scope annotation for CDI to discover it. Ignore the fields, that's just some counters for how many times those observers were notified. But here we can see 4 observers, 5 observer examples of how they can look like. You can have multiple observers in the same bean, and you can have multiple observers for the same kind of events and qualifier combinations across your beans. It doesn't really matter. The crux of it, you need to use the addObserves keyword, and what follows that is the type that you're looking for within your observer. If I have any other annotation here, it's the qualifier that I'm expecting the event to have. Otherwise, it wouldn't notify the observer. So I'm having 4 of them here. The first one basically says I'm looking just for the payload type, and I don't care about qualifiers. The second one requires fast qualifier, third one important, and fourth one has a combination of both. There's also an example of an async. just to show you that it works the exact same way. You just need to use a different annotation with it. You could again use qualifiers, whatever you want to. The payload I'm firing here is just a plain Java class, doesn't have anything in it. You can have whatever payload you want to and whatever data in it you want to. Typically, you would carry some information about what happened in your system or something that you would want to log that you would pull from this payload and then log into your output or something like that. I also have a subclass of this just to show you that you can fire with a subclass of the payload and it will still notify the observers. And if we take a look at how the event firing looks like, I said you're going to look some use some event interface to do that. So this is what they may look like as an injection points that I have in my test. You could do it different ways, but this is again a built-in bean in the CDI that it provides for me. I just say, hey, give me, for instance, the first one I say, hey, give me event of type payload and no special qualifiers. And these one already say I need some of the qualifiers. And if I then want to fire the events, it's very simple. If you have them prepared like this, you just do the fire and give it some payload. As you can say in this case, I'm using the subclass of what the observer method was actually expecting, but that's perfectly fine because the type of the event is determined at the runtime, and the event basically has a type of heavy payload, and object. And payload is what I'm expecting, so it's still a match. What you need to pay attention to is that if you're firing something like this last one, so you're firing an event that, in my case, will have the types heavy payload, object, and will go with qualifiers fast and important. This will obviously trigger the observer that we explicitly wrote for it, which was this one. But it will also notify every other observer I have in this class. This is because all of them meet the requirements of having the correct type and having at least the qualifiers I'm expecting. So this catches basically any payload type that has any qualifiers on it, and these one just have a requirement of one but can contain any other number of qualifiers. For this reason, it might be handy to sometimes use this special injection point that I have here called even metadata. It's another built-in bean from CDI that allows you to introspect the payload that you're observing at that moment. You can query it and ask it for what's the exact type that I'm actually observing, and you'll figure out that it's not a payload, it's the heavy payload one. And you can ask for the qualifiers as well. Right. Other than that, the test just observes that this does what I described, but more interestingly, if you take a look at this observer, when you talk about observers, the context in which the observer lives matters. This is a request scope bean, and as you already saw, that context is not active when I fire up the test. So if I have an observer that lives in a request scope bean and I fire an event with type string, nothing's going to happen. This is not going to be notified because the context is not active, so CDI cannot go and create the bean and notify it. There will be no error whatsoever. It's just not in the context that's active. And one other notable thing is what happens when you work with observers on dependent beans. So like I said, dependent bean is a new instance for every injection point. So you can have 1, 2, 3, n dependent beans. So what should happen if you fire an event with string? Should you choose one to notify? Should you notify any amount of these beans that exist? Oh, as it turns out, neither. CDI actually instead decides if it's a dependent bean, I'm going to create my own instance, notify it, and destroy it right after the observer call. Again, there is a test asserting it, but that would take too much time. And I also promised the observer with a reception if exists as the conditional one. We just add a value behind the observes annotation. And what this does is it says, I'm not going to notify this unless the bean has already been created. Now, when is the bean created? That's a bit tricky. CDI spec actually doesn't explicitly say that, but it kind of makes sense that it's lazy. Because otherwise, imagine you have 100 request scope beans, and now request scope comes in, and you create 100 beans, even though your user just uses one of them. Doesn't really make sense, right? Because like I said, what you're actually injecting when you're injecting your conditional observer, you're injecting the proxy. And the proxy is just an object that knows how to create the bean if it's not already in existence. So what happens here is actually this might be better visible in the test. Yeah. So I have a test that it uses a parameter in the test that's also injected by the BrnoJUG extension for me. But this is just the client proxy I'm talking about. This doesn't have the actual bean created. I haven't used any method on it. So if I just go and fire the event it's expecting, I can verify that the counter that I had there, and I had it as a static field deliberately so that I don't create the bean, it's still 0. But if I just take the bean and call any call any method on it, which I have no ping method, this will trigger the bean creation. So if I try to fire the event afterwards, it will already get notified.
Okay.
Yeah.
About the request scope, does it notify all the request scope or the one you are in, or how does it work? Because you probably want to notify just one of them. Maybe,
yes.
maybe.
Well, on the thread that you're firing the event in, you have at most one request scope bean of that type.
So you notify that one.
Yeah.
Okay.
Exactly. It would be pretty wild if it went close to that. Yeah. All right. Let's take a look at interceptors. CDI, well, actually, there is a Jakarta interceptor spec that's implemented by CDI and extended. And when you talk about interceptors in CDI, they have to be applied to those class-based managed beans. That's because you need to be able to create somehow, a subclass of it to add the interception logic. So if you have a producer that's method or field-based, that's not going to work for you, at least not out of the box. There is a way to do that in CDI full through something called Interception Factory, but in CDI Lite, you're out of luck. Now, the spec talks about something called business method invocation, which is just a nice technical term that allows us to bypass something like recursive interception happening or general object methods being intercepted. But generally speaking, if you just inject your bean and call your adopting method, that's going to be intercepted if you set up your interceptors correctly. There are various types of interceptors. What I'm going to show you is the most common one is around invoke. That's around the invocation of any method that you want to be intercepted within the bean. But you can also intercept bean creation with around construct or have a pre-destroy one that's for a bean destruction that's automatically called for you when the context is destroyed and all beans within it are destroyed. Right. Now, interceptor itself has to be enabled for it to work. That's similar to the alternatives you saw. That's done with the priority annotation. This is also good because priority requires you to have a number associated with it. And you can have any number of interceptors linked to a single bean. So the number you put in the priority affects the order in which the interceptors get invoked. Now, how do you match the interceptor and the bean? Well, that's something that's called interceptor bindings. That's an annotation. I'll show you in a bit. And there is a matching process again where the method that's being invoked has to have at least all the interceptor bindings of the given interceptor for it to match. Now, interceptors themselves are independent objects of the bean in the sense that they intercept. That sounds a bit complicated, but that basically means that if you have several beans and each of them are intercepted by the same interceptor, that interceptor instance is not shared among the beans. Obviously, you don't want to touch other people's beans. Right. Other than that, interceptors, as you probably know them from one framework or another, they don't know the semantics of the method they intercept. So you're working on something that returns like object. So it's good for cross-cutting concerns, or you have to be aware of what you're intercepting and do some casting, which is obviously not recommended. Well, there is a way to help yourself, and that's through the special metadata access at intercepted bean, where you can basically ask the interceptor, or rather ask the CDI, hey, what bean am I intercepting right now? And you can act based on that. Let me show you some of that. So first, interceptor bindings. I have two of them here called first and second. They're the same. Basically, again, runtime annotation. It doesn't really make sense to have any other target than method and type. I'll explain in a bit how that works. And you need to have that add interceptor binding that makes CDI recognize this as an interceptor binding annotation. Now, if you have a bean that you want to intercept, very simple class-based bean, like I said, so-called managed bean. And here I applied the first interceptor binding on the class. What that means is that it applies to every single eligible method in your code. So it's going to apply to your ping and pong method. It is equivalent of me writing the same annotation on all of the methods, basically. The pong method has also a second interceptor binding. So effectively speaking, if I then invoke this method, it only has first. If I invoke this method, it has both first and second. I should note that method level declaration takes priority. So if you had, for instance, annotation that has a value in it, and you had it both on class and on method, the method one wins. Right. Yeah, I should mention this. I just have a list of like classes to show you how the interception works with the method calls. So the interceptors will use this to write into this list when their invocation happens, and when the method itself is invoked, I write the name of the method class into it. For the purpose of demonstration, the interceptor itself looks something like this. Now, it is a CDI bean again. Interceptor happens to be the so-called bean defining annotation, like I used to go for beans, and interceptor is also recognized by CDI. It has to have the priority to enable it. Here, for alternatives, the priority.application doesn't make that much sense. Here it does. If you're in some more complex environment, or God forbid, enterprise application archives, right? There is a lot of interceptors coming in from your server, from your libraries, and from your own application. So there, the ordering might matter, and you might want to choose like, hey, I have a library, so I'm going to use library number for it, which can be something like 1,000, while the application is 2,000, and so on. Now this is an around invoke interceptor, and that's denoted by the method here. All of them, I think, have the description of how the method needs to look like in their Java doc. But to make it short, it always returns object, because you have no idea what kind of bean you're intercepting at that moment. So object is all you get here. You need to have a parameter called invocation content that's given to you, and it always has to be able to throw an exception. Now the crux of this is that every interceptor at some point during this invocation has to invoke invocation context.proceed method. This forwards the call to the next interceptor in the whole chain, or to the method invocation itself. If some of the interceptors let this out, it's not going to work out for you. You're going to fight very fast. The interesting part is then the interceptor can perform some work before and after the method invocation itself happens. So you can effectively grab the method call from both sides if you so wish. Obviously, you don't need to do that. Some interceptor might choose to do that. Other interceptor might only do something after the method call is over. Up to you. Now, the only thing I did here is I used the extra metadata I told you about, declared here. It's a special built-in bean, again, by CDI. You don't need to have this yourself. It needs to have the intercepted annotation added to it. There's a special marker. And this allows me to basically ask CDI, hey, give me the class of the bean that I'm currently intercepting. And here, because I know it's only one bean, I just set an equal to the bean I'm expecting, and then I put myself in its list of classes to show the order of execution. Now there's a second interceptor doing the exact same thing. The only difference here is that it has higher priority. And if you take a look at how this actually turns out to be, right, so here I'm injecting the bean using its interface to do so. And if you call the ping method, which only had one interceptor linked to it, then we have the expected order of class that should do some work, which pretty simply is the interceptor call, then the bean, and the interceptor again after the work has been done. But what's more interesting is when you do the second method where you already have at least two interceptors working. And as you can see, the second interceptor had the higher priority in this case. So higher priority with interceptors means you're closer to the method call itself. You're wrapping closer to it, which can be a bit confusing, but yeah, I guess even if it were the other way, it would still be confusing. time. Oh, we're running pretty out. I would like to show some of the extensions. So I'll just say what decorators are, leave the example. It's in the code if you want to, and hop onto extensions. So decorators in CDI, very similar function to interceptors in that you can decorate all of the calls going to a certain bean, decide to do logging, decide to return a different value, enrich it somehow. The difference here is that you're aware of the method semantics, because decorator always has to implement a bean interface that the bean also uses. Instead of matching it with the interceptor binding that you saw, here you would use something that's a special delegate injection point inside the decorator, and the type and qualifiers you use there basically determine the beans that will be decorated out of all the implementations that exist in your application. One more thing I should mention, both decorators and interceptors can not only inject the special metadata that I just showed you, but here you could just inject literally any bean you wish to. So you could, if you had a foo bean, you could just do your add inject foo, and that would work too. I have no foo bean here, so that doesn't really work. But yeah, anything works. If you want to, CDI will give you that, and you can operate on different beans while intercepting a call of another bean. Right. Let's take a look at extensions. CDI extensions, that's one of the things that CDI is pretty known for, because it's what allows many frameworks to somehow hook into it, register their beans, and tweak the deployment, basically. You can get into various stages of the deployment, you can, or of the bootstrap, let's say. You can manipulate what happens before the bootstrap even starts. You can change the metadata of the beans that you registered, or also that somebody else registered. You can, for instance, observe all of the beans that have been added to the deployment, then check some of the types, foo, and then say, oh, I actually want all of these beans to be application scope instead of dependent. You can do that. You can register fully synthetic components that, by that I mean components that are not based by any producers or by any beans. So that's actually a third way to define your beans. And I'll show you that in a bit. Extensions use service loader mechanism. We'll be talking about two kinds of extensions, both of them use the same mechanism. I assume you're familiar with it. You just have to have the meta and services entry for it to be automatically found, basically. Now, there are build-compatible extensions and portable extensions. I know the names are unfortunate, but don't worry, the build-compatible are portable as well. It's just that the name has been taken already. If you ever came across an older CDI extension, it's likely that it's the portable extension that existed since CDI 1, I guess. These ones were added at CDI 4 because portable extensions just don't work at something like a build time environment, because they carry information over from the bootstrap to runtime freely, and that doesn't really work if you have a build time environment. So we had to devise a new extension model. You can use both altogether interchangeably. They're made to achieve the same goal, so you should be able to do the same thing. Last but not least, it's the easiest way to completely break your application. You can do literally anything. You can just say, you can define a bean, tell it it's a string, and then among its times, put integer. What's going to happen? Well, it's going to blow up when somebody tries to use it. So you have to be very careful. But on the other hand, it's a little bit silver bullet. You can solve almost anything with it. You can change injection points inside existing beans to completely different types, to different qualifiers. You can register annotations that haven't been qualifiers to be qualifiers, anything. So let me show you. First of all, we're going to look at what's the CDI Lite extension. It implements some service interface. It has no methods. It's just so that the service loader mechanism works. The Lite extensions have several phases, which are demarked by the annotations I'll be using here. I think there's 6 in total, and I did some action in each of them just to show what it can do. There's more, obviously. So the first one is so-called discovery phase. This happens before the container even starts to bootstrap, starts to discover what's on your class path. There are several things you can use as a parameters that the CDI container will automatically give you. Here I use the scan classes and meta annotations. And what I'm saying is, hey, scan this class as well. This is a class that will normally not be found by CDI. If we take a look at it, this is a plain Java class, but it has no bean defining annotation. So by default, CDI would just skip this over. It wouldn't be a bean at all. And it can be something more complex, obviously. I just chose this as a way to say through an extension, hey, register this bean. In this one, I'm telling him, hey, I want you to consider the synthetic qualifier class as a CDI qualifier. Now, if we take a look at this, this is a plain Java annotation. It has no qualifier annotation, so normally if you try to use this as a qualifier, that's an error. But if you register it through an extension, it's going to start to work. Now, the second phase, enhancement, one of the more commonly used. I already told you, you can monitor every single class being added to the CDI container, and that's exactly what I'm doing here. It's highly unrecommended to do that, by the way, because if you have a big deployment, you're not monitoring every single bean that goes through, right? Just to show you that it works, I'm saying that I'm looking for beans of type object, and every bean has object, and with any subtype, so whatever the bean has. What I'm doing here is just collecting information. I'm remembering in the list names of all classes that don't come from the Weld implementation, like excluding the built-in beans that Weld give me, basically, just to show you what it can do. The other thing you can do in enhancement is modifications of the classes. So here I'm saying I'm looking exactly for the type of foo. If we take a look at what foo is a dependent bean. Nothing special to it, no qualifier, the scope is dependent. Now if we go into the extension, I'm now saying, you know what, I don't like it. Remove all the annotations the class has, and now say that the class's application scope has a qualifier important and has the new synthetic qualifier that we just registered to be qualifier in the first place. And you could do this with, for instance, if you have a library that has extension, this processing is going to catch the beans of the application itself. So you could change the beans of the application, not just your own. The next phase, registration. Now there can be multiple extensions in place, obviously, and all of them do their phases. Like every extension is going to do discovery, then every extension is going to do enhancement. So if you get to registration, you're already looking at a deployment, how it looks after all the extensions have done their changes. So here, you can inspect the bean after somebody might have tweaked with them if you want to. So in this case, I'm looking again at the foo bean that I just changed, and I'm basically verifying that, hey, it's no longer dependent, because dependent is not normal scoped, and I'm also asserting on the qualifiers that have been added. In this case, if you're wondering why there is 3 qualifiers, why I added 2, this is because CDI automatically adds any qualifier to literally every bean in your deployment. Then we have synthesis phase. Synthesis is when you can add the fully synthetic components I mentioned, that's observers and beans typically. Here I chose an example that adds a bean. And I'm basically saying add a bean that's going to be based on a string type. Say it's going to have a qualifier fast, scope dependent. And here I'm listing in types and I just kept it at string. I could list more types. But by actually doing this, I'm saying it is just a string and object that's going to be added automatically, but I'm omitting any other types. So string is, I think, implementing character sequence and other things. That's not going to be the case here. This bean is just going to be string-based. Then the crux of it all is the create with method, which defines how you're going to create the bean. Think of it as defining a producer method. This is the body of the producer method. And because we're in the not compatible extension, this has to be a separate class. I put it into the same class, but can be a separate one that implements the create method. Here you're given the instance for the programmatic lookup, so you can use any other bean that you want to during the instantiation, pull some information from it, whatever you need. And there is also some parameters coming in that I actually added here just for the sake of demonstration. This can be anything you read during the build time that you want to pass on to the producer. It's in this kind of a weird way because it's the build compatible one that can work in the restricted environments. And if you think something like Quarkus, for instance, the build and the actual execution can be completely different JVMs. So if you need to pass through some of these very specific parameters, you can do that. But obviously this is limited to something like, I don't know, the basic types, integers, strings, classes, and so on. Most of the time you won't even need that. The last part is the validation. This happens after all of the beans, even synthetic ones, have been added. You move on to the validation, which is basically if you just want to do some logging or maybe throw an error because you discovered that the application is in some wrong state. Say that you, for instance, have a library that defines an interface, and you say, hey, user, if you want to use this, you have to define a bean of this, full interface type. And so you can check for that bean in, for instance, the registration part. And if you didn't get any notification in a hit for the bean, then here you could say, you could throw an error and say, hey, you actually need to define one such bean. What I did here is just like I processed all the beans that were non-weld. Here I'm just using that to log in information with all the classes that I found. I should note that in those spaces like enhancement and registration, there can be multiple beans of this given types. I think enhancement can use also with annotations and define like what qualifiers it has. Yes?
Separated with your finish what you're.
Yes. So this is going to be called multiple times if there are multiple beans of this type. So both of them. Yeah, go on.
Is there something like priority for individual stages? Because you said that all enhancement will be called and only then it will move to registration.
Yeah.
So if somebody will change something which I already somehow saved to my build compatible extension, like your processed classes.
There is no guaranteed order that your extension will run sooner or later than someone else's extension, because oftentimes you don't even need, you don't even know if there is another extension going on or not. So what you're only guaranteed is that, discovery comes first in all extensions, then enhancement in all, and then registration in all. So yes, technically you can have issues with that, but if you have like 2 extensions hard tampering with your beans, that sounds like a problem in the first place. Okay, then just I know I'm over time, sorry, just a quick glimpse at the portable extensions will let you know. They're way older, and it shows because it has a massive amount of phases that you can hook into. But in practice, it basically achieves the same goals. These ones are application life cycles that only happen once. So you can hook into the container before any discovery starts, after it has seen some types, after it has transformed them into beans, after it has validated it, and before it has shut down. The ones you see below are, for instance, the process annotated type is very much like the enhancement phase we saw. It's for each bean of given type. I'm going to show that here. And just 2 of these as a showcase. So first one, like I said, very similar to enhancement, and this has a syntax similar to the observer methods we saw. Note that you cannot do observation in extensions, just a synchronous way. And here we're basically declaring what kind of bean are you looking for. So here I'm saying anything that implements the bar interface. Now, if you remember, bar wasn't even a bean. It wasn't valid. The other extension added this bean, and my extension is now building on top of that and somehow changing it. If the other extension didn't add it, this would just not fire at all. And it's no problem. You can have observers for certain things that never happen in the application, and that's perfectly fine. What I'm doing here is just similar to the enhancement. I'm saying, hey, add a different scope to it. Lastly, I'm using the after bean discovery method here, or hook, to define my own observer method. This is what it looks like in the portable extension. It's much more user-friendly. You don't need any special class. You basically just say, hey, add me an observer method, and then start defining the observe type. This is what you would normally place after the add observes annotation. So you're looking for an integer. You say that this has the synthetic qualifier annotation. Again, this is not even a qualifier unless the other extension adds it in the first place. Bean class is just for completeness. If anyone asks, like, who added you, it's going to show this extension. And the core of it is notify with, where you define what happens inside it, just like the body of the observer method. Since you're in portable extensions that assume that it all happens in runtime and you can carry over the state, you can just use lambda to declare the whole functionality, and it's pretty simple. What I'm using here is just some kind of a counter. And the reason why I did that is because, let me show you, what was that? Yeah, there are instructions for every various things that I did here, but what I want to highlight is this. CDI full extensions can be injected anywhere as a bean into your application. This is also why they are not a good candidate for like a build time environment, because you can literally store anything from the build time, from the metadata like the process annotated types to whatever other configuration you had during the bootstrap, and pull it out here and work with it. Here I'm just using it to gain access to the field that remembers how many times the notification happened, basically. Yeah, here's just the illustration of what I tried to describe. Okay, I'm over time already, so that's it for me. Thanks for the attention. If you have any questions, I'm happy to answer them, probably in next doors, I guess.
You can take it if you like. If people are not that hungry, you can take it for questions.
Right, go.
Well, I'm interested if you have any native compile time optimization, or if that's something the frameworks above it are adding.
That's something the framework does. For instance, the CDI-like implementation in Quarkus, which is called ARC, does basically that. The whole processing, bean creation, proxy creation for beans, all of that happens in the build time.
And it's Quarkus implemented, not CDI implemented.
Yes, yes.
Okay.
CDI doesn't have any limitation or any like guidelines that would declare this basically. And the spec is written, originally was created for a fully runtime environment. So that would be basically too limiting to like hard code it into the spec. Any other questions? Did I bore you to death? Yeah, that was a lot of it. I just tried to capture as wide area as I could. Okay, that's it then.